All right, guys, this is chapter 12, section 2. It's on frequency and histograms, just statistical measures. They go together. So we have a home run derby in which they have home run hitters that hit a certain number of home runs. One hit 7, another hit 17, 14. That's a 4. 2, 7, 9, 5, and 12. 3, 10, and 4. 12, 7, and 15. Oops, let me get that a little bit further apart. All right, so there's all of our home run totals. What we're going to do is what's called a frequency table. And a frequency table usually is best if you break it down into sections, about 4 or 5 different sections. And it's the number of home runs versus the number of times it occurs, which is called frequency. All right, so what you want to do is you want to get even little distribution areas here. So the first one, we're going to do 2 to 5. Well, think about it. 2, 3, 4, and 5 has an interval of 4. So the next one also needs to have an interval of 4, 6 to 9, 6, 7, 8, and 9. Then we go to 10 to 13, which has 4, 10, 11, 12, and 13. And then 14 to 17. Then for a frequency table, guys, all you do is you count up the number of times that occurred. So let's find all the home run hitters that hit between 2 and 5. There's 1, 2, 3, and 4. So the frequency from 2 to 5 is 4. Well, let's try 6 to 9. There's 1, 2, 3, 4 also. 10 to 13. Let's see. 1, 2, 3. That's a 3 right there. I'm just going to erase it and make it look a little bit better so it's clean. And then 14 to 17. 1, 2, 3 also. And so there's our frequency table. We have 4 people that hit between 2 and 5, 4 that hit between 6 and 9, 3 that hit between 10 and 13, and 3 that hit between 14 and 17. All right, so that's generally what we'll be doing with frequency tables. We'll break it up into equal intervals. I like to have in this section at least 3 or 4 different interval levels. Sometimes they'll give it to you. Sometimes you'll just have to kind of break the numbers down. Just make sure the intervals are equidistant. All those that we just did involved home runs of 4s. All right, finish erasing there. All right, let's get another set of numbers. This is the number of hours per week that a group of students spent watching television. So we've got 7, 10, 1, 5, and 14, 22, 6, and 8, 0, 11, and 13, 3, 4, 14, and 5. Whoops, that's a 14. And that's a 4. So 4, 14. Whoops, I did it again. 14 and 5. Okay, so we've got to break these numbers apart. We're going to do hours, because these are the hours of TV watching, and the frequency of those hours. Well, just look at this, guys, and you can see that my smallest is 0, so it needs to start with 0. And my biggest goes all the way up to 22. So if I do 0 to 5, 0, 1, 2, 3, 4, and 5, that's an interval of 6. So I've got to go 6, 7, 6, 7, 8, 9, 10, and 11. So it's 6 to 11. There's 6 there too. And then 12. There's got to be 6 of those. 12, 13, 14, 15, 16, 17. So 12 to 17. And then 18 would be 18, 19, 20, 21, 22, and 23. So 18 to 23. All right, so there's my hours intervals. Each interval has 6 between them. And then we just got to find the frequency and document it. So 0 to 5. Here is 1, 2, 3, 4, 5, 6. Okay. 6 to 11. 1, 2, 3, 4, 5. Looks like 5. 12 to 17. 1, 2, 3. And then 18 to 23, just that one right there, which is 22. 6 plus 5 is 11. 11 plus 3 is 14. 14 plus 1 is 15. So I should have 15 data points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We've got them all covered. Now, here's what a histogram is. A histogram, it's not a bar graph, but it looks like a bar graph. It's a graph, so we need a title. So let's title it Watching TV. Okay. In a histogram, the frequency will always be on the left here. So this is going to be the frequency. And then what are we measuring here? We're measuring hours of TV watching. My little marker here is not working real good. All right, so that's frequency versus hours of TV. And then what you're going to do is you're going to block it off into the different intervals you had. So we had 0 to 5, 6 to 11, 12 to 17, and then the last one was 18 to 23. Now, with a histogram, you do not want to have any space between it. So 1, 2, 3, 4, 5, and 6 up there. It's got to go all the way up there. And then you just do bars. How many do we have of 0 to 5? 6. So we do a bar all the way up to 6. That's the frequency. How many do we have between 6 and 11? 5. So we drop down 1. There. How many do we have 12 to 17? We had 3. Let's go up to 3 and across. And then how many do we have from 18 to 23? Just 1 way down here. And then you can look and you can see that this is kind of a step down situation. The highest was the least frequency of 0 to 5, and then it started going down like that, and you get a bar graph which you can interpret. So there is a frequency table over here on the left and a histogram over here on the right. Histogram has frequency on the y-axis and whatever you're measuring the frequency of on the x-axis there. All right, so let's erase these. Now, there are certain types of histograms and shapes of histograms that are very common statistically. If you had taken the home run hitting histogram and you had taken the frequency table that we did of home runs, you would have noticed that the frequencies were all very similar. 4, 4, 3, and 3. Okay, so all the bars would have been about the same height without much change. That's one type of histogram. The frequency table that we just did on TV watching by students during the week, that one was weighted on one side. It was much higher on the left side of the graph than it was on the right. So those are two different types of histograms. Let me give you a depiction of them. If you get a histogram similar to the one that we did with home runs, those histograms look very similar in terms of the sizes. This would have been the histogram. Okay, that was the home runs. You see how they're all about the same height. That is called uniform. A uniform histogram generally is about the same height. Okay. Now, the type of one that we just did, you'll notice that there was a peak on the left. It was up here, then it went down a little bit, then it went down a little bit more, and then it went all the way down there. Okay, this is called skewed. A skewed histogram has a peak that is not in the center. Notice the peak is on the left side. Uniform, there really is no peak because they're all about the same. And then the final one is called symmetric. Let me draw you an example of that. A symmetric histogram looks similar to this. Where you'll notice that the peak is in the center of the graph. This is called symmetric. It's almost like a ladder on both sides. Whoops, forgot the E. Okay, so again, the uniform histogram was the one that we did with the baseball home runs. The skewed histogram was the one that we just did on watching TV by the students. We didn't really see a symmetrical one, but it'll naturally show up. All right, last thing. You can also do what's called a cumulative frequency table. Cumulative frequency tables just gives you kind of a measurement to see the part to the whole. And it accumulates all the different measurements that have gone before. I'll show you in just a second. Let me erase this. Takes forever to erase all of these little lines, so I apologize. Unfortunately, this particular program does not have an erase all. I would use it.